Here is the next example based on the clipper circuit. In this question, he's asking about draw the input-output waveforms and transfer characteristics of the given circuit. Here we have two diodes. So here is diode D1 and D2. So there are total, we'll end up having four possibilities. Both diodes might be acting like open, both diodes might be acting like a closed, and one is open, another one is closed. Okay. Then how do we determine how these diodes are acting? I would go with, start solving this example by assuming one diode is closed and the diode is open. That's how I'll start. But say if I assume both diodes are open, if the both diodes are open, V0 is going to be how much? There is a 2 milliampere current is passing through it and 2 kilo ohms there. So V0 could be anywhere between 10 volts and anywhere between 10 volts and 0. Okay, so there is a possibility of at least one diode is closing or one diode is closed. Another way of looking at it is there is a 2 milliampere current source here. The 2 milliampere current has to pass through in one of the paths. So there is a possibility one diode is going to act like a closed all the time. So here I'm going to assume for time being this diode D2 is closed and D1 is open. Here I'm assuming a constant voltage drop model. That means I'm assuming there is a 0.7 volts drop across the diode. So if this is the case, I'm assuming this diode is closed, another diode is open. Now I can clearly see the voltage at V0 in this case. V0 equal to, or V0 minus 2 must be equal to 0.7 volts. So if it is VAB, this is VAB 0.7 volts, this is VA and this is VB. VAB equal to VA minus VB. Based on that, you can tell V0 minus 2 equal to 0.7. So V0 equal to 2.7 volt. Now I need to find out the condition. That condition must have what will be the Vin value, then we will end up with this V0 value. So here I assume D1 is open. So when that is going to be open? When V0 minus Vn must be less than 0.7 volts, then only this diode is going to be open. So I know V0 equal to 2.7 volt. So 2.7 minus Vn must be less than 0.7 volt. So if I bring the 0.7 to the other side, Vn must be other side. So 2 volt must be greater than Vn. So basically in this case, if my input voltage is greater than 2 volts, then my output voltage equal to 2.7 volt. Okay, so this is one condition. Now I'm going to assume another diode is so D1 is closed and D2 is open. So here is the circuit. So in this case I'm assuming D1 is acting like closed, D2 is acting like open. D1 is acting like a closed, that means I'm assuming there is a constant voltage drop of 0.7 volts. Now from here I can tell V0 minus Vn must be equal to 0.7 volts because the voltage here is V0 at anode of D1 and cathode of D1 is Vn. V0 minus Vn must be equal to 0.7 volts. So V0 equal to 0.7 plus Vn. Now I need to find the condition. So I'm assuming this diode D2 is open. So V0 minus 2 volts must be less than 0.7 volts. Then only this is going to be open. Now I'm going to substitute V0 value right there. So 0.7 plus Vn minus 2 must be less than 0.7. So if I bring the 0.7 to the other side and to also other side, so as long as Vn is less than 2.7 volt, then V naught equal to that. So if Vn is less than 2.7 volts, my apology, isn't it 2 volts here? Because 0.7 get cancel out and we'll end up with 2 volts. My apology there. If Vn is less than 2 volt, then V naught equal to 2.7 volt. So this is another condition. So if you look at here, if input voltage is greater than 2 volts, that's my output voltage. If input voltage is less than 2 volts, then that is my output voltage is 0.7 plus Vn. V naught equal to 0.7 plus Vn. Okay. So for if you take the whole cycle, I'm going to draw the input and output waveforms. Sometimes we need to consider the other condition too, like both diodes are closed, both diodes are open. But here I don't need to do that because my input voltage is changing from 10 volts to negative 10 volts. Now, the first case, as long as input voltage is greater than 2, I know what is output voltage. So, as long as my input voltage is greater than 2, so for above this part, I know what is my output is. Now, if input voltage is below 2 volts, then I know my output voltage is. So that is the reason I don't need to consider the third case. Sometimes you may end up with so if this is the whole cycle, sometimes you know what is going on in this part. You know what is going on in this part, but we don't know what is going on between these two values. Then we need to come up with the third condition or third case. The third case might be both diodes are open, both diodes are closed. So here is my output waveform. So you can see as long as input value is less than 2 volts, my output is 0.7 plus Vn. So I'm going to draw a straight lines. So up to 2, my input voltage. So if input voltage is less than 2 volts, so that's the 2 volts. That is the 2 volts. Input voltage is less than 2 volts, output voltage is 0.7 plus Vn. So if input voltage is 0, what is my output? 0.7. So basically my output value is going to start at 0.7. It follows the input voltage up to what value? Up to, so maximum I can go up to 2 volts. So 0.7 plus 2, 2.7 volts. So here the starting point is 0.7, ending point is 2.7. Okay, now it's going to clip at that value based on the above condition. So if input voltage is greater than 2 volts, my output voltage is going to be clipped at 2 volts. It's 2.7 volts. So it is going to be clipped at that point, and when it comes down, the negative waveform, it's going to follow the whole thing. But the only thing is, here it says less than 2 volts. If the input voltage is less than 2 volts, output is this much. So if my input voltage is negative 10, what is my output? 9.3 volts, negative 9.3 volts. So basically the waveform is going to be shifted 0.7 volts. Okay, so this is how it's going to be look like. I need to draw these lines a little bit different. Hold on. Okay, so at this point, this is 0.7 volts. Okay. At this point, this is 0.7 volts. At this point, that must be 0.7 volts. Okay, so that's 0.7, that's 2.7 volts. This is how the output waveform is, and the negative side is negative 9.3. Now when I draw the transfer characteristics, okay, here is my input and output. So the dotted line is input. Here that's a plus 10 volts, that is minus 10 volts. Now my output waveform, look at it, it is shifted. So starting at 0.7, so output is, when the input is 0, my output is 0.7, and it will follow same as the input, but it goes up to 2.7 volts. So here input is 2 volts, but my output is 2.7 volt. Okay, and it is going to be flattened. So even the input is varying from 2 to 10 volts, my output is constant at 2.7. Now on the reverse side, it follows same as the input, but basically it is going to stop at 9.3. So here this must be negative 9.3 volts. So this white line is the transfer characteristics. Okay, thank you. I will solve one more example based on this Clipper circuit. Thank you.